load. For this is the circuit diagram. From frequency generator to this voltage divider network, we have to connect the input to the base capacitor and record the output between these two terminals. This is the circuit for gain with load. These two wires are here. These red wires you have to use to make the connections of variable resistor. For that, these two resistance boxes are given to you. You require this high voltage, and for that you have to make the connection between these two wires as a RL variable, that is variable resistance, load resistance RL. From the generator, this positive wire is connected to the potential divider arrangement of R3, RL, R3 and R4. The middle terminal, this negative wire is connected to this negative, and this middle terminal wire you have to connect to the input. Here you have to connect from this battery for biasing of transistor. This wire connect over here for biasing of transistor. This negative wire, black wire of battery, is connected to the ground terminal, and in between these two red wires make the connection of this load resistance RL. So this first terminal of RL to one wire, and the another terminal of another resistor to this red wire, and these two are coupled by one wire. So two resistors are in series by connecting these two. So you can use the high value of resistances by selecting the resistance value from R1 and R2. This is the complete circuit diagram connection. First, set the input voltage from this generator. From the generator, 20 millivolt adjusted by using this knob. Select the frequency from this knob. This frequency selector plus this knob multiply by this selector. So if it is 20 and this is on 100, so this is 20 into 100. If it is on 10, so 20 into 10 is 20, that is 200 Hertz. So this frequency you can change with the help of this knob and this knob. Then from this battery, 9 volt is connected for biasing of this transistor. Connect this meter across these two terminals to measure the output. So for input frequency, which is selected here, start with the 10 Hertz, 20 Hertz, 30 Hertz and so on. And for this low frequencies, we have to see the value of the output. First select here the value of RL from this resistance box. But in this experiment, for gain with load, you have to keep the frequency of this generator is 1 kilohertz. So this is on 10 multiply by 100. So 10 into 100 is 1000 Hertz. Frequency is fixed, and change the value of load resistance starting with say 100 ohms. So here I take out the value of 100 ohms, press all keys tightly and record the output voltage. It is showing two divisions are shifting, so it is 0.4 volt is the output for this resistance 100 ohms. Now increase the value of resistance and make it 200, and see that voltage is increased and it reaches to 0.8 volt. Then make it say 500. For this 500, the voltage output voltage is 1.2 millivolt. In this way, increase the value of resistance up to 1000. Let us say this is for 2500. The voltage reaches to 3.4. Go on increasing, and for high value, this is now 7500. The voltage output voltage is 5 volt. Again increase the value of resistance. Now for 17500, it reduces and becomes the 4.4 volt. Again if I increase the value by 5000 ohms, now voltage is reduces to 4 volt. Again if I increase by 10,000 ohms, the value of the output reduces and it comes to near about 3 volt. Again if I increase the value of resistance, I am finding that the value of output, that is output value across these two terminals is going on decreasing. So as resistance increases, the output voltage is going on decreasing. As the load resistance we are going on increasing, the output voltage is initially going on increasing. As value of resistance is going on increasing, output voltage is going on increasing. It will remains constant for some ranges, and after remaining constant, it starts reducing and becomes low. And for such high value, near about 30,000 ohms of RL, the value reduces to 2 volt, and from that we have to calculate the gain AV equals to VO upon VI. VO is this value and VI is, we have selected 20 millivolt. 20 into 10 raised to minus 3. You divide this value with this value to this in output voltage. You will get the gain, and for that gain and the frequencies you have to plot the graph. You will find the nature is going on increasing, the output voltage remains constant and reducing. And for this gain with load, you have to find out the value. For which values you are finding the maximum gain, that values you have to record from this graph. So for these are the values here. For what values you are getting the constant maximum gain, that values are 9,000 to this maximum value 15,000. For this band you are finding the maximum constant gain.